So we're into lesson 3.3 now. We can talk about lights in Unity, and this is very important in the context of theatre. I'm a lighting designer by background in theatre, so of course I'm a little bit biased here. Now, the important thing to remember about lights is that lights use up a lot of processing power. The lights in in Unity, that's a Freudian slip. The lights in Unity are very efficient. They're designed to be quite good at generating light in real time at 30 to 60 frames a second, depending on your system, without putting too much pressure on the hardware. But the more lights you have, the more resources it will use. So there's some clever tools that you can use to optimize the lights, such as baking, which we'll come to much later in this course. But for now, we're just going to look at a few lights, because you can definitely run a few lights in real time. Even on a mobile device, you're allowed a few. And we'll just sort of see how that works. So if I right click here, and I've got my lights list, and here are all the types of lights we can use. Now the main ones: directional light, point light, spotlight, and area light. They kind of all do what they say, and you can flip them all around and change them after you build them. So let's create a point light. Now what I need to do is just put something in the scene so we can actually see what's going on here. So I'm just going to create a plane, which is going to sit underneath it. I'm going to scale it up with my R key to select scale. And then I'm going to add a couple of spheres, which I'm just going to dot around like that. I'm going to press Control C and V to copy it, paste it. And another one. Let's give it an interesting name. Must have been hitting my ERW keys while it was on. So there's a few balls, and I'm also going to turn off my directional light for a moment. So I'm just going to hit light here. So let's turn that off. And you can see it's still trying to render the sky. Okay, that's why you're seeing some light there, is that the sky itself generates light, which is a whole other thing we'll come to another time. But I'm going to grab this point light and I'm just going to pick it up, and you can sort of see the reflection it's creating in the plane. It's because there's a default material assigned to it. And as I move this around, look, I'll bring it closer to this, get it in the right place. Drag it over here closer to this sphere. You can see how it's generating light on it, and it moves around. So it's doing that in real time. That's really cool. And if you have really good quality materials, you'll notice that renders in lots of detail, the bump textures and norm maps and things that if you understand what they are, that you'll know that can be quite time consuming for a renderer to process. In here, it's all in real time. So a couple of things to know about lights, and the point light's a good one to experiment this with. I'm going to put it in the middle of these three spheres there, and you see I've got a range here, and the range is what we're seeing with these lines. It's how far this light can see. Now sometimes you change the range, it feels like the intensity is changing, but intensity is a separate command, and we can do that by just dragging this up here, and you can see that I'm putting more light on the sphere. So because I've turned off my directional light, but the sky sphere is still creating light, it's got a lot more to compete with. So now I change my range, you can see how it's picking up those first two spheres, but not the one of a distance. And now it's picking up the one of a distance. And it seems to get brighter as I get larger, but what it's doing is just putting more light on the scene. And because the light has a logarithmic exposure over, so as you get further away from the source, the light level starts to halve in what they call the inverse square law. So obviously it gets brighter the closer it is to the source. So if you're increasing the range, what you're saying is this is a really big light. So that's range. You've got the color option, obviously, so you can make that blue, whatever you want to do. And then we've got the shadow types, and we've got three types of shadows. You've got no shadows. So if I drag this over, so we right on top of this sphere here, hopefully this will work, and we can't see a shadow on the floor. I'll then change that to hard shadows. And there we go. Now we've got a shadow which is it's hard. It hasn't got a very soft edge. It's not very realistic, but useful if you're just trying to do quite technical understanding of your lights relative to scenery, to see how lights get through holes in the set, for instance. But it does use a lot less rendering power than soft shadows. Soft shadows does a lot more processing. So if you've got a sort of a slightly feathered edge, or you've got a bump map or something, it will try to process that too. Not so visible with this particular setup, but you'll see it. And real-time shadows, this is just different things you can change the quality settings to try to make it more efficient. And you've got your mode. And the mode is really important. You've got real-time, mixed and baked lights. I talked about baked earlier. It's like it's baked. The idea is it starts to process that information and it saves the lighting data into the object. So then you can move this around, it won't change anything. The light will stay there. Each time I move it in the scene, it's processing. You can sort of see it in the corner here. If you watch the bottom right corner, I move it, it says it's global illumination is being updated. It's processing it. But some lights don't show that in the scene view. And I think point light's one of them. Area light, for instance, says baked only. You just can't see it unless you do baked. If you do mixed, you can see that light source and you see it's trying to process it at the bottom there. So what this means is that the light will update every time you try to move it, which is really helpful. But when it's finished, it will process that light and bake it in, so it doesn't then have to keep trying to update what the light looks like in real time, 30 times a second while your game is running. But it does mean that if you move all your lights at once, they'll all try to process global illumination and update their bake map at the same time, which may slow your game down. So you need to judge whether or not it needs to be real time or mixed. But mixed is really cool. If you always have mixed, then you'll always be able to see what you're looking at, and it will run efficiently if the lights aren't moving too much. I'm going to leave it on real time for the moment though. Then I'll change the point to a spotlight. Spotlight is exactly what you expect it to be. It's a spotlight. You can spot things with it. So there we go. There's my light. I can move it around. And it's got a cone that comes out of it. Now this is where some of these tools for local and global are quite handy. Okay, so I've got a gizmo here that's in the direction of the light, which is really helpful. But you might want to swap that to global, which means that then I can move it around in the XYZ position. So it's harder than if you want to try and like point it at something, but you've got that sort of flexible control if you want to. You can choose one or the other. And you've got a couple of options here that you don't have in point lights, and that being the inner and the outer spot angle. So I'm going to open up the outer angle, which creates sort of the very extent of the beam, and then the inner is the inside of the beam. And you can see if you pull it right out so they're together, you get a sharp edge, and you pull it in, you start to get a soft edge. And you can pull the whole lot in and out as well. They have just updated this. It used to be two separate sliders, which was a bit confusing. So you can get a nice sharp edge if you want to. And yes, you can add in things like gobos. We'll cover that at a later time. But you can put in images, which are called cookies, to be able to create nice patterns and things. The other thing that you might want to do is increase the range to be able to get it to work. If it sits before the thing you're lighting, you see that's just intersecting it, you're only going to get light where the range is reaching the object you're trying to light. So you need to push it right beyond. Now, I mean, you could just go on to a ridiculous amount, make it almost infinite, because you know that light is always going to want to interact. You don't want to be caught out by a light that's not reacting with the scenery the way you want it to. So I can light right over there and know that it should reach all the way, and we know that that's a true representation of the light. It does have to do more processing though, and it's really important to be thinking about optimizing your model the whole time and keeping all those little details down wherever possible to save unnecessary processing, because game engines can eat up a lot of processing power. So you might want to just say, okay, it's going to go about there, let's just pull the range back so it's just sitting just underneath, and now we know it's catching it, and we can modify our cone. Let's just bring it in nice and tight, make it slightly sharp, and then I'm going to stick it in the direction of my sphere there. There we go. It's got a nice shadow on the floor. There we go. And then the other one we got here is, we've seen the directional light already, which is just, it lights everything at once. And I've really ramped up the intensity there, so that's why it's whited out. So there's a directional light. And we've got an area light. Now area lights are pretty cool because they create nice big flat lights. This is more familiar if you work in film studios. Make it wider, make it higher. It only works in baked mode, so you won't see this until you go into the play view, which is why it's really important to test out what you're seeing in the game view at some point. So you've got an area light which just floods the whole area. The light comes from all corners of this from every direction. So you get a nice big flat light, like a big light, LED light panel, which you might be using for lighting people or for lighting large areas. We don't see many of those in theatre, so I would tend to stick to point lights for anything that might be like a house light or something that sits on the set as a practical. The vast majority of things are going to be spotlights, because that's what we use in the theatre industry, is various forms of things that project light out. So profiles, finials, and you may have one directional light, which is really handy to have, so you can control some working light. Because when you're working in your scene, sometimes you've got it all lit very nicely, but you just can't see around the corner because it's creating shadows. So just have one directional light, have no shadows on it, nice and bright, and it will always light whatever it's seeing. And I've got it on bake, that's why I can't see it. There we go, real time. There we go. And then, oh no, too far. And then no matter what I'm doing, that will just light everything. It will cut through all the scenery. It won't like create shadows as it goes around objects. It's just a light. It just always works, and it lights everything equally. So that way you can really inspect your model when you're trying to work. So that's the end of lights. In the next section, we're going to talk about audio actors.